Okay, hello and welcome to lesson 7-3, ratios with fractions. So today we're going to go ahead and we're going to continue with what we're talking about with ratios. It's very important to remember that ratios and fractions are different. And now we're going to be able to see how ratios actually use fractions. So let's go ahead and start with our anticipatory set. For our anticipatory set today, I want to take us back in my football days. So back when I played football, we would have this workout. Was not a super fun workout, but it was a workout that we did that's our field right there. And we would all line up on this side of the field. We would all be standing here, the whole team. All right. And then the coach would just tell us to go. And what we're doing this was called gassers. So we called them. So what you would do is you would run as fast as you could over here. And then when you touch this sideline, you would run as fast as you could back. And you would go back and forth as many times as the coach wanted you to. So to run across from here to here as fast as you could, you had to run 53 1/3 yards to get across a football field. 53 1/3 yards to run from here to here. And we did this all the time. We did it over and over and over again. I felt like I was pretty good at it. I got in pretty good shape, and I was able to run that, and I was able to keep breathing. So one time we were not in football season. I decided to, you know what? I got to stay in shape for next year. I got to make sure that I'm gonna stay in shape so that I can keep playing. And so I decided, okay, I'm gonna go work out with the soccer team one day. So the soccer team did a similar drill. I don't remember what they called it. But so I went over there. So here's me over here. And we did the same drill, but with the soccer. And I started and I ran. Oh, I remember. Oh, it's so easy. Got to this side, touched the sideline, ran back. But I was exhausted. It was the hardest thing I'd ever done. Because what I didn't know at the time was that soccer fields are 75 yards wide. So as you can see, obviously, 75 yards is a lot worse than 53 1/3 yards. So what we're going to sort of be talking about today is about trying to compare these two numbers, comparing things like this. Okay, so let's go ahead and get started with our lesson with our standard. And our standard today is 7.RP.1. So it's the same standard we've been using. And yes, we are going to write it down one more time. So what this standard says is compute unit rates associated with ratios of fractions. Including ratios of lengths, areas, and other quantities measured in like or different units. And then it has an example. So for example, if a person walks half a mile in or each quarter of an hour, compute the unit rate as the complex fraction 1/2 to 1/4 miles per hour. Equivalently, (2 miles per hour). All right. So yes, it's a bit of a long one, but I'm glad we have that down. It's very important. What I want us to look at here, there's a few interesting things here. Today we're getting into exactly what we want to make sure that we're knowing. So as you can see, it says compute unit rates associated with ratios of fractions. And we are doing today ratios with fractions. So we're going to really get this part of the standard. Now, lengths, areas, other quantities measured in like or different units. So either units that are the same, which is easy, or units that are different, which gives us a few extra things we need to do. So as you can see here, this is in miles and this is in hours. Those are different units, but we're able to figure that out. Okay, so let's get right ahead and move on into our input. There is no language of the discipline today, none at all, because we've already learned all of the terms we need to know for this material. So instead of our lips today, we're just going to go ahead and draw our flower. And the first bit of our input is going to be ratios with one fraction. Ratios with one fraction. Okay, so let's take a look at what we do when we have a ratio with one fraction. So let's just start with a little reminder of what we need to do. You must rewrite the ratio where both terms are whole numbers. Very important that we know that's what we need to do, because that's really what we start off with. So I'm going to go ahead and write down an example that we're going to be using. The example I'm going to write down is 4/5 is to 6. So that's our ratio. Now it looks very strange. We haven't seen things like this before because it's ridiculous to put a fraction on top of a fraction. So 4/5 to 6 is what we're doing. So let's go over here on the side and write down what our steps would be. Step 1. Step 1 is to multiply each term of the ratio by the denominator of the fraction. Okay, so what will that do for us, though? Why is this what we do? Multiply each term of the ratio by the denominator of the fraction. If we're trying to get a whole number, that's what we're trying to do. What can we do here to make these things whole numbers? Well, here's the denominator of our fraction. So what it's saying, what our first step is saying, is to multiply this by the denominator. So we multiply by 5 and multiply by 5. But why are we doing that? Well, obviously on the top and bottom we have to do the same thing. But if you remember, any number can be written as a fraction. And we can write this as 5/1. Meaning, when we move on to our next step, the 5s will cancel out. 4 and 1, we're just going to put that over. So now it's going to be 4/1, 2, and then 6 times 5, which is going to be 30. Now, obviously, we know we can write 4/1 as 4. So now the ratio is just 4 to 30. So now let's get to our step 2. And this part should be easy for everyone. Write the ratio in simplest form. Write the ratio in simplest form. Okay, so let's go ahead and take what our number is right now, our ratio, 4 to 30. And what number is going to be able to go into both of those? Well, we can divide 4 by 2, and we can also divide 30 by 2. And that'll give us 2 to 15. Can't simplify that anymore. Our ratio is going to be 2 to 15. And look at that. We only have 2 steps. Not so bad. Not so bad. We find the whole numbers by multiplying each term, and then we simplify our answer. Okay, let's go ahead and move on to another page and finish up here. It ripped at the top. I'm so angry. That's okay. Okay. The next thing we're going to do for our input, it's going to be another one of our flowers. And this one is going to be a little bit more complicated. Now, instead of ratios with one fraction, now we're going to say both terms are fractions. So what if what we're doing has both terms as fractions? Now, it's going to look even stranger. I'm going to go ahead and put our terms over here. I'm going to say 3/4 to 6/7. Right there. So that's what we have. We have a fraction and then another fraction in a ratio. So what are we going to do now? Our first step needs to change, right? Our first step needs to change because back in our notes, step 1 said multiply each term of the ratio by the denominator of the fraction. Well, now we have 2 fractions. So what's our step 1 going to be when there's both fractions? Well, let's take a look. Step 1. Step 1 says multiply each term by the least common multiple of the denominators. All right. So now instead of just the denominator, there's 2 fractions. It's a little bit more complicated. We need to find the least common multiple. So our denominators are 4 and 7. What would the least common multiple of 4 and 7 be? Well, the first thing that 4 and 7 can go in together is going to be 28. There's nothing lower than that both 4 and 7 go into. Okay, so now we have our lowest common multiple. Now what we do is we multiply by that. So we multiply the top by 28, which we know will be 28 over 1. And come on. There we go. And we're back. Hopefully, we didn't miss too much. Hopefully, it's all working. Okay. Okay, here we go. So, just to recap, since we had a nice little break there, just to recap, when you have 2 fractions in a ratio, your step 1, instead of multiplying by the denominator of the fraction, since there's 2 fractions, you need to multiply by the least common multiple of the denominators. We found that 4 and 7, the least common multiple, is 28. We then multiply by 28 on both sides. Then we just have to make sure that they become whole numbers. Then we go with step 2. And step 2, again, is just to write the ratio in simplest form. So now we have 21 to 24. What can go into that? Well, we can have 3 go into 21 and 3 go into 24. 3 goes into 21 7 times. 3 goes into 24 8 times. Now we have 7 to 8. We can't reduce that anymore. And that is going to be our ratio. So that's all of it. With one term is a fraction or 2 terms are fractions. You just need to remember that the step 1 changes. Okay, so now what we're going to do is we're going to do sort of a little hybrid input modeling. Because there's one thing, one little skill we haven't quite gone over yet. And that's going to be if we input units into this. So, number 1, I'm going to say we have 3/4 of a gallon, 2 9/10 of a gallon. So now we're inputting terms or units. So that's going to make things a little different. Okay, so when I go over and do the steps this time, I'm going to add a new step, but I'm just going to call it step 0. Step 0. And what step 0 does for us is we just need to find like units. Find like units. Well, if we look back over here, gallons and gallons. Okay, we've already found like units. So that's good. So step 0 we can ignore. Then we go to step 1. And step 1 is then what we do with all of them is to find the whole numbers. We're finding the whole numbers. In this one that we're doing right here, we have 2 fractions, meaning we need to find the lowest common multiple of these 2, which 4 and 10 can both, the quickest thing they can go into is 20. So we're going to multiply the top by 20, which is 20 over 1, and the bottom by 20, which is 20 over 1. And we're going to get a new number, a new ratio. 20 times 3 is going to give us 60 over 4 times 1 is 4 over 20 times 9 is going to give us 180 over 1 times 10 gives us 10. Let's go ahead and get our new number with whole numbers. Oh, forgot to tag these as gallon. 60 divided by 4 is going to give us 15 gallons. 180 divided by 10, that's easy. 10 takes off that 0. It's going to be 18 gallons. Step 2 is to simplify. So what number can go into both 18 and into 15? Well, that would be 3. So we go ahead and divide by 3, divide by 3, and we get 5 over 6. And this says gallons and gallons. Now, finally, we have a little end step, which with ratios, so I'm going to add this in a step 3 here. With ratios, we always want it to be simple, so we cross out units. Since they are the same, we can cross them out. And we do that because we're just talking about a ratio, a relationship. We're not doing a fraction. You might want to say gallons, 5/6 of a gallon. But remember, we're doing a ratio, which is 5 gallons to 6 gallons. So since it's just a ratio talking about the relationship, we can cross those out. And our answer is going to be 5 to 6. So for every 5 gallons, someone else would get 6 gallons. Okay, so now that you've seen those extra 2 little steps moved in, let's do a little bit of a more complicated one as our last one. And this is going to be number 2. Now let's talk a little bit about football again, okay? A football field is 53 1/3 yards wide. find the ratio of the width of the actual field to the width of a field in a poster, and I'll give you that, which is 1 1/2 feet, as a fraction in simplest form. Okay, so let's go ahead and take a look at how we can do this. First of all, let's look at our two numbers, 53 1/3 yards, 1 1/2 feet. Well, yards and feet are not the same thing. So first of all, we need to find what that conversion is. Well, most of us should know that there are 3 feet in 1 yard. 3 feet in 1 yard. Okay, so we're going to use that conversion first, because if we remember, and I'm not going to write them again, but step 0 up here says find like units. Well, we do not have like units yet. So we are going to be solving and trying to find feet. So let's take our number that is not feet, which is right here, and we have to go ahead and say 53 1/3. Now, we can't quite do it this way either, because we need this to be a whole number. So 53 times 3 plus 1 to get our improper fraction equals the same thing as saying 160 over 3 yards. And then we're going to multiply this by our conversion, which is 3 feet over 1 yard. Now, the good thing about this is our yards now cancel out. We are left only with feet. Also, our 3's will cancel out, leaving us with 160 feet. Great, now we have a whole number that is in the correct units. So let's look at step 1. We're finding whole numbers. Well, we found 1, so let's write our problem, which is going to be 160 feet over 3. Now, sorry, I got a little ahead of myself. Our next number right here is 1 1/2 feet. But again, we can't have this mixed number there. So 1 1/2 feet, 1 1/2. 1 times 2 is 2, plus 1 is 3, so we're going to have 3 over 2. We should know that already. That's an easy skill from a long time ago. Okay, so now underneath, we're going to have 3 over 2 feet. Okay. We do not have whole numbers yet. However, we only have one fraction. So to find the whole numbers, we are not finding the least common multiple. We are just multiplying by the denominator. Our denominator is 2. So the top will multiply by 2. The bottom will multiply by 2, which we can say is 2 over 1. The 2's here will cancel out. And our new number will be 320 to 3 over 1, which we can just say is 3. Now, step 2 is to simplify. Now you can look at this, see if 3 will go into 320. Well, I know 3 can go into 300 100 times, right? So can 3 go into 20? No, 3 cannot go into 20 evenly. There's nothing we can do there. It's already as simple as possible, except that we still have feet and feet. But step 3 is to simply cross out the units that are the same now. So our ratio is going to be 320 to 3. That's the ratio of the size of the real field to the size of the field in the poster. And that's everything this lesson is teaching us. So we're going to go ahead and I'll write down our guided and independent practice for today. Our guided practice is just going to be lesson 7-3 guided practice. It is assigned on your Pearson site. Then our independent practice is going to be on Front Row Ed. And we're going to be doing our assigned practice for 7.RP.1. And yes, you have done that before, but you constantly want to get the practice on that standard. Okay, that's everything. Hopefully that little place in the middle isn't too messed up, and we'll be able to actually watch this video. Okay, have a great day and go Buffs.